Hi, welcome to Chapter 5. Chapter 5, we're going to get into this thing we call loop. We basically do the same lines over and over again until some type of condition arises for us to get out of that particular item. The chapter, they call it a repetition structure. So there's going to be 6 different sections we're going to cover today. So let's get started. So it says in here, programmers commonly have to write code that performs the same task over and over. For example, suppose you have been asked to write a program that calculates a 10% sales commission for several salespeople. Although it would be a good design, one approach would be to write code to calculate one salesperson commission and then repeat the code. So here it is. So we've got declare real sales and commission, both decimal numeric values. We got a constant, which is 10%. And then we have display enter the amount of sales, set the commission equal sales times commission rate. Display the commission is commission. Display enter the amount of sales, input sales, set commission. So as you can see, we're duplicating lines of code. Whenever we duplicate lines of code, we either want to do one of two things. We either want to loop it or we want to put it into a module so that we can basically execute that module. We never, ever, ever want to duplicate lines of code. If we do, then let's loop it if we can, or put it in a module that we can. And the reason for that is let's say I've got these duplicated lines of code in 10 different spots in my program. If one of those are, let's say the calculation in this case is commission rate. Let's say commission rate changes or the calculation changes. I have to find all 10 places where that code is to make those changes. Instead, what if we had that in a separate module? Now, every time I go through this loop, I'm calling that module to do the calculations. I only have to basically do that code, change that code in one place. And same way with our loop. So, what we need to work on or concentrate on is once we get into that loop, we have to have a way to get out. So that's where there's condition controlled and count controlled loops. Basically get into those. So if we take a look at a flowchart, it's going to look a lot like a decision structure, except you'll notice that the branch comes around back before the decision structure. So it's going to keep coming back into that same condition until that condition has some type of value that causes the loop to stop. It's going to basically keep going through that same repetition. So we're going to do this condition while it's true. Come in here, come in here, come in here, come in here, and then we basically come out when it's false. Now, does it always have to be true or false? I would say for the most part it's usually going to be true. Rarely would we do some type of a false condition. But this is called the while loop. We're going to do this while this condition is true. Okay? And we're going to do some type of task. The way it looks in pseudocode, we say while. Notice we have an end while. So while some condition, we do some different commands or whatever we need to do within that loop, and then we hit the end while, which basically takes us back up and we check that loop again. So here's how it looks. So here is a, there's the commission rate. So we've got our declare real sales and commission. We declare a string called keep going and we go ahead and initialize it to yes, to the letter Y. We have our constant real commission, which is 10%. Notice that the constant is always in uppercase so that we know we're dealing with a constant variable. We say while keep going is equal to yes. We then say display enter the amount of sales. We input the sales. So we display it on the screen and then we get whatever the user types in. We then set the commission equals the sales, what we just typed in, times the commission rate. That goes into commission. I display the commission is $, and then the commission. And then I say, do you want to calculate another? Display commission, enter yes, Y for yes. Okay, so if we get a Y, notice we come back up to this loop up here. Well, we go ahead and input to keep going, and we hit end while. Now the very next thing it does is automatically goes right back up to this while statement, and it checks that statement again. If that statement is true, it goes ahead and goes inside of it. Okay? And it keeps doing that until we enter anything but y. Once we enter anything but y, it will basically hit this end while. It will come all again after we hit the end while. We always come back up to this while statement, and if that statement is now false, we will then get out of that loop and continue on. Okay. So again, that's kind of what they're talking about here is, again, every time we hit this end while, we always come back up to this loop and we check this while statement, and we check to see if the statement's true. Okay. Now, when I earlier said if something is false, we can actually set that to a false statement, but that false statement, and this is kind of weird, that false statement has to be true, meaning while keep going not equal no, then we're just going to keep going. So that's a false statement, but that false statement has to be true. So just kind of those are some different ways we would normally use the why. Now, before I go on, if you look at that statement, we've got a lowercase y. What if they typed an uppercase y? What would that cause that to happen? Well, if keep going is equal a lowercase y, is that statement true? No, because it's an uppercase while, that statement is false, and it would basically drop out of that loop. So make sure we basically keep that in the back of our mind as well. Here's what it would look like in a flow chart. Here we have our start. We declare our real sales commission, declare I like how they did this. They did all of our declarations in one box. That's kind of nice. And keep that, if you're doing flow charting, make sure you understand that as well. Declare everything in one box, and then we come in, here's our keep going. If keep going is equal y, if that is false, look what we do, we end the program. But if it's true, we come in and we just do our displays, we get the input, we set our commission, we go ahead and display the commission, then we display, do you want another one? If we enter, please display lowercase y to continue. Then we input that keep going from the user, we come back around and see, did they type a lowercase y? If they did, we go through that whole process again. And as soon as they enter anything but a y, we basically will drop out of that loop and continue on. Now, one thing we need to really understand is the while loop is what we call a pre-test loop, meaning we test it right here. If keep going is not equal y, it will basically fall straight through to the false side and not even go through that loop. So when we talk about a pretest, what we mean by that is there is a chance that we won't even go inside of the loop, because that first test could be false and it won't even cause us to go inside of it. So I'll go through this first spotlight, but again, I want you guys to go through these on your own to really get a feel for how this works. So project currently underway at the chemical labs. It requires that a substance be continually heated in a vat. A technician must check the substance temperature every 15 minutes. If the substance temperature does not exceed 102.5 degrees, then the technician does nothing. However, if the temperature is greater than 102.5, the technician must turn down the vat's thermostat, wait 5 minutes, and check the temperature again. The technician repeats these steps until the temperature does not exceed 102.5. The Director of Engineering has asked you to design a program that guides the technician through this process. So here's the algorithm. Okay, so these are the steps that need to happen. Get the substance temperature. Repeat the following steps as long as the temperature is greater than 105. Tell the technician to turn down the thermostat, wait 5 minutes, and check the temperature again. Get the substance temperature. After the loop finishes, tell the technician that the temperature is acceptable and to check again in 15 minutes. So here is the pseudocode for that particular program. So again, the first thing we do is we declare real temperature. So we want, because it's 102.5, so we do need a decimal place. We have a constant real max temp of 102.5. So there's our constant. Notice it's all uppercase. We display enter the substance temperature. We get the temperature. So now we've set everything in motion. We've got our variable. We have our constant temperature, 102.5, and then we've gone ahead and got the actual temperature from the user, and we now have that in our temperature variable. Then we come into our while loop. While the temperature is greater than max temp. So if it's greater than max temp, if that statement is true, that meaning the temperature we just got from the user is greater than 102.5, we're going to go into this loop. We display the temperature is too high. We display turn the thermostat down and wait. Display so the temperature is too high, turn the thermostat down, wait 5 minutes, take the temperature again, and enter it here. We input the temperature. So there's an assumption made here that while this loop is going on, we're going to turn it down, we're going to wait 5 minutes, and then we're going to check the temperature again, and we're going to input the temperature. Okay, if this was a real program, we'd probably have some type of a clock program that would basically count down 5 minutes and then tell the user to input the temperature, or turn it down and then turn it down, and then the clock program would run 5 minutes and then tell them to input the temperature again. So we come back around and we check that again. Again, as soon as that statement is false, we drop out and we display the temperature is acceptable, check again in 15 minutes. So this could actually, this while statement could be, and we might see this later, could be a loop itself that runs every 15 minutes. Okay, so here is, we typed in 104.7, the temperature is too high, turn down the thermostat and wait 5 minutes, take the temperature again and enter it here. 103.2, the temperature is still too high, blah, 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 blah. 102.1, the temperature is acceptable, check again in 15 minutes. Okay. This is what it would look like in pseudocode. We have start and we have end. If you do decide to do flow charting, I would really like to see main, left parenthesis, right parenthesis in here. I'd like to kind of get you interested in that, and down here would be end module. So just a little side note. So we declare our real temperature and constant. We display the substance temperature and we input the temperature. So again, we set everything in motion. And here is where our loop starts. If the temperature is greater than max temp, which is true, we come in and we say display temperature too high, turn down the thermostat and wait 5 minutes, take the temperature again and enter it here. We input the temperature and come back around and check to see is it greater than the constant. Now the nice thing about this constant is if we decide to maybe 102.5 is too high, maybe 102.1 is what we want to change it to, we just change that constant right there and it basically changes the entire program. So that's kind of nice as well. Infinite loops. These are the types of loops we really have to avoid. What it means is we have no way of getting out of the loop. So here is a good check. So we've got our real sales and commission. We have our string keep going equals y, constant real commission rate 10%. And it says while keep going is equal y. We do this and we say display the commission rate is. Notice we do not ever get input from the user as far as do you want to keep going. So what is going on here? This y, this keep going, never changes. It never changes to anything but y. So we are now in what's called an infinite loop. It keeps going around and will run forever. So let's talk about modularizing the code. That means taking this section of code out of the loop and maybe instead of doing the code within the loop, do it in a module somewhere else. That way there we have two pieces and parts that we can kind of maintain. So we've got, here's our declare string keep going equals y. While the keep going equal y, so while that statement is true, we call show commission. Okay, so we come down here to show commission, and it basically declares real sales and commission that has the constant real commission or commission rate. Display, enter the amount sales, input sales, set the commission equal sales. So again, the meat of the program is now inside of this module. Look how short this main module is, and look how long this other module is. But we can really see the logic flow inside of this program right here. So what's nice about this is one person can maintain this program, another person can maintain this module, and now we have two separate parts that two separate people can then maintain. So here we've got while keep going. We call the show commission. Also another thing is, let's say this commission rate is needed in another program. We can very easily take that module and use it over here as well. So again, notice we have our where we display to the user, do you want to keep going, yes or no? We basically display that to the user inside of the main and not inside of the show commission. Why? Because the show commission has a specific job to do, and that job is to calculate commission. It does not interact with the user as far as do you want to continue, because show commission doesn't know how this is being used. It has one job: display, calculate, get the input from the user, display the commission, and basically go on. That's it. So, and here's how it looks in a, again, that should be main and end module, but they got start. So here is start, declare your string, keep going. Here's keep going. We call the show sales commission or show commission. Display, do you want to calculate another? Enter lowercase y for yes, and input that and come back around. And then here's our show commission. We declare all of our variables and our constant. We display, enter the amount of sales. We input the sales. We set the commission equals sales times commission rate. We display that commission rate, and then we return. Notice it doesn't say end. So here's a do while loop. Okay. Now a do while loop is a little different in the fact that we are always going to execute what's inside the loop at least once. At least once. And so what happens is we come into the loop, we actually do the statement, then we come into the condition. And if the condition's true, we come back around and we keep doing that statement. Now we're in the regular loop. Okay? But notice we're going to do this statement at least once. So what does it look like in pseudocode? We just have a do statement. So let's just do this. It does it, and then our while check is at the end of the loop. So that's where we check to see, do we need to continue on with the loop or basically drop out. So here is our declare string keep going. Do, call show commission. Display, do you want to calculate another? Display commission, blah, blah, blah. While keep going equals yes. We come back around to the loop. So what's going to happen is these lines right here are going to execute no matter what. They will always happen at least once. Then we check, do you want to keep going? If it's a no right there, we're going to basically drop out of that loop and hit the next line, which happens to be in module, and we are done. And our show commission is exactly the same as it was in the previous one. There's no change. The change is now in this main. And again, what's nice is, even though we changed the logic in our main, it didn't affect the show commission. The show commission is exactly the same as it was in the other program. So this is how it would look in the flow chart. As we come in, we declare our keep going. Here's our sales show commission. We do the display, do you want to do another? And at the end of the loop is when we check to see, do we want to continue on with the loop or not? Okay. Again, please do these in the spotlights. They will really enhance what we're going to do. Okay, so a do until loop is just the opposite as a do while, in that we are basically doing this while this is false and we want to do it until it becomes true. Okay, so I kind of alluded to that at the beginning of this chapter, that we can actually check for false as well. But I talked about how we can actually have a false statement, and we can check to see if that false statement is true or false. In this case, we want the condition to be false, and we are going to do it until it becomes true. Okay, so we come in, and this is a do until. So we basically do our statement, and if the condition is false, we keep doing that, keep doing that, keep doing that until it becomes true. Once it's true, we drop out. I don't know why they just didn't bring that line straight down here. I don't know why they had to come off to the side, but it's their preference. So the way we do it here is do statement, statement, statement until the condition, meaning the condition right now is false. We want to do it until it becomes true. So here's a declare string password. So it's a textual string, and we're going to basically say do display enter password, input the password. If the password is not equal Prospero, then display sorry, try again. And then we say until password is equal Prospero. If that's false, it's going to basically come back up to this do statement and do it all over again until this statement becomes true. Once it's true, it will basically drop out. Okay, so this loop is not going to basically stop until you type in the correct password. Okay, which is probably not good for password checks, because hackers, they can find passwords pretty quickly if they've got an infinite number of times to check. So we probably want to do that maybe a few times and then basically drop out. So this is what it looked like in a flowchart. We declare our string password, we display enter the password, we input the password, and then we check if the password is equal Prospero, or if it's not equal Prospero. This is that check where we're checking a false statement to see if it's true. So password not equal Prospero. So that's kind of weird. But while the password is not Prospero, we're going to come in and say sorry, try again. And basically, that's kind of weird. Oh, this is okay. This is an if statement. My bad. So this is an if statement, and again, the reason I got confused is it was two diamonds. But anytime that the branch comes off and goes down below, that's an if statement. Anytime the branch comes off and goes back up to the top, that's a loop statement. So again, we come in, and if the password's not equal Prospero, we say displayed sorry, try again, and then we come down and say if password is equal Prospero, we hit false, come back up and around. Now, why didn't we put this sorry, try again here at the end of the statement? Because it would display no matter what. Kind of weird, but yeah. Because there's no place to put it since we're doing a check at the end. Let me show you what I mean by that. Here's our check. If that statement is false, there's no way to display sorry, try again after that. We have to put that in an if statement. So that's why we come back around and we have our if statement here. So which loop do you use? So it basically says we've introduced three types of condition statements: the while, do while, and do until. You want to use the while loop to repeat tasks as long as the condition is true. The while loop is a pre-test loop, so it's ideal situations where the condition might be false to start with. So use a while loop if there is a chance you never ever want to go through the loop, meaning it's going to have a false statement from the beginning. We want to use a do while if we want to do it at least once, and then basically loop around and keep doing that process again. So if you want to do it at least once, do while. Use a do until if you basically have a false statement and you want to do until that false statement becomes true. Now, the thing about a do until and a do while, they're really one and the same. It's just how you kind of word your check. So do you want to check to see if the statement is equal to something or not equal to something, or so you can create a true statement or false statement. So they're both basically kind of one and the same. So let's say we have a loop that we want to go through a certain number of times. Okay, we could do that with a while loop, but there's a better loop to do that with, and it's called the for loop. And the for loop is a loop that says we are going to do this loop this many times. So we come in and we have a counter equals starting value. So we have some type of numeric value in this thing called counter. And while counter is less than or equal to max value, we're going to basically, if that's true, we come in, do our statements, then we add 1 to the counter, we come back around. So what we've done here is we know we want to do this loop max value times. Okay, that's what we've said. So while this is basically less than that, we are going to always basically keep doing that until we basically reach that max value. Now, a for loop is a pretest loop, meaning this could be false and we might not go into the loop at all. But more than likely we will. So here we have declare integer counter equal 1. So we declared a variable called counter. It's an integer data type. We set it to 1. While the counter is less than or equal to 5, so it looks like we want to do this 5 times. We come in to say display hello world. We add 1 to counter. We come back around. Counter is now a 2. Is it still less than or equal to 5? Yes, it is. We display hello world. We add 1 to counter. It's now a 3. Is 3 less than or equal to 5? Yes, it is. We display hello world. We add 1 to counter. It's now a 4. Is 4 less than or equal to 5? Yes, it is. We display hello world, add 1 to counter, come back around. Is 5 less than or equal to 5? Yes, it is. We come back around, display hello world, add 1 to counter, we come back around. Is 6 less than or equal to 5? No, it's not. That's false, and we drop out. Okay, so here is how it looks in a pseudocode. We say for some counter variable equals starting value to max value. We do these statements and we have our end for. Okay, so here's how it would look. We have a declare integer counter, constant integer max value equals 6. So there's our max value. It's 5. For counter equals 1 to max value. Okay, we display hello world, and then we have our end for 1, 2, 3, 4, 5. Okay. Here's how it looks in the flow chart. Declare integer counter. Here's our constant, max value equals 5. We set our counter equals 1. While counter is less than or equal max value, we display hello world. We add 1 to the counter. Now the one thing I want to point out here, in the for loop, we have to do something that causes that, what do they call it up here? The counter variable. We have to do something to that counter variable to cause it to increment so that we can get out. And that's what we're doing right here. If we did not have this, we would then have an infinite loop because counter would never change, and that basically for loop would go forever. It says using the counter variable in the body of the loop. In a count-controlled loop, the primary purpose of the counter variable is to store the number of times the loop has iterated. In some situations, it's also helpful to use the counter variable in a calculation or other task within the body of the loop. For example, suppose you need to write a program that displays the numbers 1 through 10 and their squares. So we could do that very, very easily by doing this. We declare our integer counter and another variable called square. We have our constant value, which is max value equals 10. We display the number, tab, and square. Okay, so notice we have kind of a unique variable here. We have the word tab, has no picks around it, which means It is a variable, but it's also it's basically, we're going to call it a reserved word variable. I mean, it's like hitting the tab key. So I'm going to type the word number, I'm going to hit the tab key and then type the number square, or type the string square. Then I display this dashed line and I set the counter equals 1. Then I come into my for loop. Okay? While the counter is less than or equal to the max value, and it is because max value is 10 and the counter is 1, I come in, I set the square equals counter, which is basically a caret symbol 2. Caret symbol is basically an upside down V, and I believe on our keyboard that is the shift number 6 at the top row there. So if you put a caret symbol 2, that's the number times itself. That's a square. So that would be 1 times 1. We display counter, the tab, and then square. You also notice that the tab is an uppercase letter. Whenever we basically deal with reserved words, those are always uppercase. We always want to keep our variable names lowercase. Okay. I'm sure start with lowercase. So we display the counter, we hit the tab key, and we display square. In this case, it'd be 1, 1, and then we add 1 to the counter. So, so we come back around. Counter, so we've added 1 to the counter. It's now a 2. Is 2 less than 10? Yes, it is. Less than or equal to 10. We go ahead and set the square is equal to counter times itself, which is 2 times 2, which is 4. We display the counter, we hit the tab key, we display the square, we add 1 to counter, and again we're going to do that time and time again. This is what it looks like in pseudocode. We have our declare integer counter and square. We have our constant integer max value 10, so it's all uppercase. We know it is a constant variable. We display number, tab, again it's getting the tab key on our keyboard, and square. We display the dashed line, and then we do our for loop. For a counter equals 1 to max value. Now what that means is we're just going to go from 1 to max value. And notice that we do not have to do, with the for loop, we do not have to do a 1, add 1 to the counter. We have to do that in our flow chart because we do not have a for loop that we can utilize. So that way we do have to use the add 1 in a in a flow chart. In a pseudocode, we do not. It's assumed when I say 1 to that particular item, it's going to increment automatically. It does that automatically. A for loop will do that for us automatically. So I got for counter equals 1 to max value. So we set square equals counter times itself. So the first time through it's a 1. I display counter, hit the tab key, square. When I hit this end 4, it automatically adds 1 to the counter, to the variable counter. We come back around and the counter is now a 2, and this is where it does the check. So on line 13 here, that's where it's basically doing a check. Is counter less than or equal to the max count or max value? If that's true, it's going to go ahead and go into the loop. And every time we hit the end 4, it automatically adds 1 to the counter. When it comes back up to that for loop, that is like an if statement. Is the counter less than or equal to the max value? So it keeps doing that. So basically this is what it looks like. Notice we've got number, here's a tab, it's like hitting the tab key, and square. There's that dashed line. There's 1, tab 1, 2, tab 4, 3, tab 9, 4, tab 16, so on and so forth. Now, can we increment instead of 1? Yes, we can. We can use this word step. So here I say for counter equals 0 to 100, step 10. Now what that says is, at the end of this for loop, when it hits this end 4, instead of adding 1 to that counter, it's going to add 10. So whatever's in this step statement is what gets added to that variable. If we were going to do this in pseudo or in a flow chart, we would have to would basically look just like this, except right here it would say add 10 to counter. So again, whenever we see a counter less than or equal to max value or something to that effect, and we add 1 to that counter, that's a good indication that, hey, that is a for loop. Okay. We may even want to maybe put some kind of a comment in here, or maybe a little parentheses. This is a for loop. So whoever's going to write the code from this flow chart knows that we are basically trying to do a for loop. Okay, so remember that so if I wanted to do a for loop that said, hey, I want to show all even numbers between 0 and 20, I would basically say for counter equals 0 to 20 step 2. So that means at the end of every for loop, it's going to add 2 to the counter as opposed to just 1. If we don't have the step, pretend there's a step 1 in there. That's kind of the default. Okay. And again, please go through the end of the Spotlight. They have some very, very good examples in there. So what if I wanted to go backwards, meaning I wanted to go through this for loop, but I want to go from 10 to 1? Well, very easily I would say for counter equals 10 to 1, step -1. Now, if I left that step statement out, what's the default? That would be step 1. So this would basically never happen because that statement is basically false. Okay? So again, step -1 means we're going to display the counter, which is 10. When we hit the N4, that means we're going to add -1 to the counter, which now becomes 9. We come back around, are we still within that range, 10 to 1? Yes, we are. That statement is still true. We display the counter, which is a 9. We come down here to N4. We add -1 to counter, which is now an 8. Are we within the range 10 to 1? Yes, we are. And we basically keep doing that till we basically get down to 0. 0 will cause that to basically drop out of the loop. So here we have declare integer, counter, square, and upper limit. Display, this program displays numbers starting at 1 and their squares. How high should I go? Input upper limit. So in this case, we want the user to set how high do you want to go? You want to go to 10, you want to go to 20, you want to go all the way up to 100, whatever the case may be, it's going to do that. So then we say display number, we hit the tab key, and then show the word square. We have our dash line. Now we have our for loop. For counter equals 1 to upper limit. Notice there's no step statement in there. That means it's going to default to 1. It's going to add 1 to it at the end of every for loop. We set the square equals the counter times itself. We display counter, hit the tab key, and then the square variable. And when we hit the N4, we automatically add 1 to the counter and come back up. And we're going to keep doing that until we hit this upper limit. Once we are 1 past the upper limit, because we will go to that upper limit. So if I've typed in 20, so think of that as saying we're going to do that while it's less than or equal to the upper limit, is really what that's saying. So if I said 5, it would basically do 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Now, do I always have to start with 1? No, I do not. I can say display this program displays numbers and their squares. What number should I start with? That's our lower limit. What number should I start with? Or which number should I end with? Set the upper limit. Now I'm going to basically come into there and say for counter equals lower limit to upper limit. And since there's no step statement, it's going to basically increase by 1 each time. So if I said I wanted to start with 3 and go to 7, that's exactly what it would do. It would start number 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, and then it would basically drop out of that loop. Now, again, I could do the same thing with the while loop. I said that earlier. So here I declare my integer counter equals starting value. While counter is less than or equal to max value, we're going to do all those statements, and then we basically increase our counter by 1. This is how we would show our counter increasing by 1. Counter equals itself plus 1. And then we hit our end while. So here we have declare integer counter equals 1. Here's our constant integer max value equals 5. We have our, while the counter is less than or equal to max value, we display hello world, and then we set the counter equals counter plus 1. And again, so the first time through it's a 1, displays. Right here it now becomes a 2, 3, 4, 5, and then we basically drop out. So here we're going to basically show what we've been doing with the for loop, except this time we're going to use a while loop, and we declare integer counter equals 1. We declare integer square. We have our constant max value, which is a 10. We display a string number, the word number, hit the tab key, display the word square, and we display the dashed line. While the counter is less than or equal max value, we set the square equals counter times itself. We display the counter, hit the tab key and square, and then we set counter equals counter plus 1. And we come back around. So as you can see, we have a lot of different options. We can use a for loop, we can use a while loop. They all are going to basically produce the same amount of basically the same output. I could do this. I could say counter equals counter plus 1. That increments it by 1 each time. Or I could say counter equals counter plus 2. That's going to increment by 2 each time. So however you want to do it. And they basically show that example here with the while loop going through adding 2 each time, which is basically showing all the odd numbers between 1 and 11. So 1, 3, 5, 7, 9, and 11. We could also do the same thing with the decrementing. Basically going backwards. I want to go from 10 to 1, and so we do that with the loop here. We basically have our integer counter equals 10, our minimum value is a 1, and we say while the counter is greater than or equal to min value, we display the counter. We display the counter equals counter minus 1. So we're subtracting 1 each time from the counter, and there we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Okay, so continue on. Now we want to basically calculate a running total. So we want to have a loop process that keeps a running total going all the time. So we're going to maybe get some input from the user, and then once we get that input, we're going to add what the numeric value is to a grand total. So the very first thing we do is we set our accumulator equals to a 0. We say, is there another record to read? Now we're reading records. And if we do have a record to read, we read that next number, we add that number to the accumulator, we come back around. So here we are reading a record. We're reading each record, which happens to be a numeric value. We keep taking that numeric value and we add it to the total accumulator. So here's how it would look in pseudocode. I declare my integer number. I declare my integer total equals 0. Now the reason I set it to 0 is up here, this guy is basically nothing right now. There's nothing in there. It's called a null value. It's the lowest form of any data called null. It's nothing. I cannot add anything to a null. A null basically is non-numeric. It's a non-string. It's non-anything. It's absolutely nothing. So if I want to add anything to this total, I have to have it set to something. So that's usually what we do when we are using any type of accumulator, is we always set them to 0 in the beginning so that we can keep adding to them as we go on. So then I have my integer counter. I display this program will calculate the total of 5 numbers. 4 counter equals 1 to 5. So here I've just gone ahead and said go from 1 to 5. And we don't have a step statement, so that means it's going to increment by 1 each time. So display the number, we input the number. So each time so again, this number here now has a value in it. We set the total equals total plus the number. So the total right now is 0. We got a number, we basically add it to it. And so that's all it's doing. So we go through and we get 5 numbers and we add it to the total. And we go ahead and display the total is the total. So here it looks like we entered the number 2, we entered the number 4, 6, 8, 10. The total number is 30. This would look like in a flow chart. We start, we declare our variables. Notice our total is set to 0. We display the program will calculate the total of 5 numbers. We set the counter equal to 1. While the counter is less than or equal to 5, while that statement is true, we're going to come in and say enter a number. We get that number. We go ahead and say take the total equal the total plus the number. So we're going to add the number to the total. And we set the counter equals counter plus 1. We come back around. Okay. So anytime we see a counter, a situation like this, we add one to the counter, that's a pretty good indicator that is a for loop. Okay, so now we have this thing called a sentinel. Now a sentinel is kind of a weird variable in that we've already seen a sentinel. We had a sentinel with the Y statement. So we basically are allowing the user to keep going through the loop until they enter something in. Or we can have a sentinel that maybe it's a numeric value. Once that gets to a certain numeric value, it basically stops. Okay, so here we have, it says every day the clerk in the tax office gets a list of properties and has to calculate the tax for each property on the list. You've been asked to design a program that the clerk can use to perform these calculations. Okay, so here we have declare a integer lot number, display enter the property's lot number, display so it's display enter the property's lot number or enter a 0 to end. Okay, so what we're doing is we are going to do this and we're going to use a sentinel as a way to stop this loop from happening. So we're going to keep asking the user for this lot number, and when we're done we type in a 0 and that stops the loop. Okay, kind of like there's really no difference with that and a Y. We could have done the Y statement as well. Do you have another lot number to enter? Y. So while lot number not equals 0, we call show tax down here. We display into the lot number for the next property or 0 to end. We input that lot number and here's our end while. So again, our meat of the program is down here in the show tax. We declare a real property value and tax. We have 2 variables that are real. We have a constant tax factor 0.0065. We display into the property's value. We input the property value. We set the tax equal to the property value times the tax factor. We display the property's tax is and then the tax rate. So this would look like in a flow chart. We have declare integer, this is our start, declare integer lot number, display into the property's lot number or 0 to end. We input the lot number. Is a lot number not equal 0? If that's true, we then call show tax, which declares a real property value and a tax. We have 2 variables there that are real. Our constant tax factor 0.0065. Enter the property's value. We go ahead and display the enter the property's value. We input the property value. Then we set the tax, our tax up here, equals the property value times the tax factor. We then go ahead and display the property's tax is $, and then we display the tax variable. We return. Display the lot number for the next property or 0 to end. Then we input the lot number and we continue on. So in this case, the lot number is the sentinel. Okay, we have what are called nested loops. These are loops inside of loops. Ooh, that'll blow your mind. So probably the best one ever is a clock. we really have, with the clock, we have three things going on at the same time. We are counting seconds. And once a second reaches a 60, we increment the minutes. And when minutes reach 60, we increment hour. And so we can basically do that within a loop. We can say, let's just go down here. So 4 hours equals 0 to 23. Minutes equals, so now I got inside of that I got another for loop. Minutes equals 0 to 59. Inside of that we have seconds equals 0 to 59. And we display hours, colon, minutes, colon, seconds. So the first time going through this, it's going to display 0, 0, 0. We're inside of the seconds loop. It's going to display 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, all the way up to 59. So it's now 0, 0, 59. We hit this for loop. We come back up and it says 4 seconds equals 0 to 59. We hit that. So we get out of this loop. We hit this end 4. We come back up to minutes and we increment minutes by 1. We come back down and we do the 4 seconds 0 to 59 all over again. So now the first time through that loop, it's 0, 1, 0, 0, 1, 1, 0, 1, 2, 0, 1, okay? And it's going to basically, when it goes around 60 seconds, it increments minutes by 1 again, so it's going to be 0, 2, 0, 0, 2, 1, 0, 2, 2, so on and so forth. So now we're at 59. So let's say we just incremented this from 58 to 59. So it's 0, 59, 59. We hit the end of that for loop. We increment it by 1. Boom, we drop out of that loop. We increment it by 1. Boom, we drop out of that loop. We've now hit this for loop. We come back up to the top and we increment hours by 1. We come in, we start this loop all over again. We start this loop all over again, and now we come in and display 1, 0, 0, 1, 0, 1, 1, 0, 2, and we go through the whole process all over again. So nested loops. This is what it would look like in a flowchart. Declare integer hours, minutes, and seconds. Set hours equals 0. Hours, while they're less than 23, we set minutes equals 0. While minutes is less than or equal to 59, we set seconds equals 0. We come in while seconds is less than or equal to 59. Well, if that's true, we display hours, colon, minutes, colon, seconds. We increment the seconds by 1. Come back up. We keep doing that until we drop out. Then we hit the minutes drop out. Oh, we set minutes up by 1. We come back around, do this whole loop all over again until hours are greater than 24. So here we have declare integer num students, declare integer num test scores, declare integer total, declare integer students, declare integer test num, declare real score, declare real average. We got a whole lot of variables going on here. We display how many students do you have. We input the number of students. Display how many test scores per student. We input the number of test scores. For student equal 1, 2, number of students. We set the total equals 0. We display the student number, we display a dash line, and then we have another for loop inside of there. For test num equals 1 to number of test scores. So now we're going to show the number of test scores for each student. So then we go ahead and then at the end of that, so once we've displayed all the test scores, we show the average test scores for that student, and then we display the average for the student is. Display, we hit into that for loop, come back up, do the next student. Do that whole process all over again. So we entered 3 for the number of students, 3 for the number of tests, enter the test number 1, sorry, it's a 100. Test number 2 is 95, test number 3 is a 90. The average for that is a 95. And then we show test student number 2, student number 3, and then we're done. Okay. Okay, so I really can't stress enough, you really need to make sure you keep track of what is called the variable scope. What I mean by that is you cannot use a variable unless it's been declared. It has to be declared. And also remember, when you're using a variable and maybe you need to pass it to a module, make sure that you know that when you pass it, are you passing it by reference? Or are you passing it by value? Meaning, if that variable gets changed in the called module and you need to come back, are you using that variable again? If you are, you better have passed it by reference and not by value. Because remember, when you pass it by value, you're passing a duplicate of that to the module. If that gets changed, the original still stays the same. So very, very important that you remember that. Again, if you have any questions, please call me. I'd be more than happy to help.